Hey guys, today we are going to take your knowledge of distributive property that you hopefully mastered the last 2 days, and then we're actually going to mush it with the greatest common factor. So you're going to get to see that today. So you're actually going to continue your notes in your packet that we started on Wednesday. So this is just like the next slide. So this was the third slide, I think, on the page that you left off on Wednesday. Just to show you, here are your notes from Wednesday. It's the rectangles. Here is your warm-up that we're doing today. And then it also has like the distributive property and greatest common factor rectangle on this page. And we're going to do that. We're going to finish that page and then do the next two together. So finding that warm-up for me, please. Okay, once you find it, I would like you to use the distributive property to rewrite these. So this one, you're just using the normal distributive property, and then this one's the reverse. So hopefully you remember how to do that. So pause and work on the warm-up for me. Okay, so in the first one, you want to distribute the 4 to both terms or both numbers inside the parentheses. So you would do 4 times 3 plus 4 times 5. 4 times 3 is 12 plus 4 times 5 is 20, and there you go. 20 plus 12. And then the second one is in reverse. We're actually going to pull out what number was being distributed. So you want to look for a number that's in common, which they have the 7 in common. So the 7 gets pulled up out front, and the 3 plus 4 is left. So that goes inside the parentheses. And that's all you had to do. Okay? So all of these are in your notes. So following along in your notes with me, please. So just like I said Wednesday, where the greatest common factor is weird because we're doing it a different way than your brain wants to do it, same thing's going to happen today. Okay? So I'm going to give you a sum or 2 numbers being added together. And I want you to rewrite that sum as a product of their greatest common factor and another sum. So it's basically going to look like this. So a multiplication problem between the greatest common factor and another sum. So we're kind of going to do like a double reverse distributive property. Okay? So I promise, not super hard, but we're just going to put a couple skills together that you're already aware of. So it is a couple steps. So I'm going to have you rewrite 12 plus 16, and we're going to change it into a multiplication problem. So the first step is to always find the greatest common factor of the 2 numbers. So I'm going to use my cake method. If you use the trees, go for it, but I'm going to use the cake. So I'm going to use the cake, and I'm literally just going to write it right around 12 and 16. My prime numbers I need to divide by, I write on the side. Oh, I forgot. 7, 11, 13. So I know 12 and 16 are divisible by 2. Draw your next layer. 12 divided by 2 is 6. 16 divided by 2 is 8. Oh, they're still divisible by 2. 3 and 4. I cannot divide 3 and 4 by a prime number. So 2 times 2 is 4. So the greatest common factor of 12 and 16 is 4. Okay, so then you're going to take that and go to the next slide. So I found out that the greatest common factor is 4 by using my cake. So after we find that out, we're actually going to rewrite each addend, which are the 2 numbers being added, as a factor pair containing the greatest common factor. So notice I wrote 2, here's one factor pair, and then here's another factor pair. And they both have the greatest common factor in it, which is 4. So then you ask yourself, 4 times what gets me 12? Well, 4 times 3 is 12, so the factor pair would be 4 times 3. And then I have to do the same thing for 16. I'm breaking down 16 into a factor pair. 4 times 4 gets me 16. Okay? So I literally took 12 and wrote a factor pair. Took 16, wrote a factor pair. So it would be 4 times 3 plus 4 times 4. And that should look familiar. We did this on Wednesday. Once you have those factor pairs, you're going to do the reverse distributive property like we did Wednesday. You're going to pull out the greatest common factor and you're going to write whatever is left in the parentheses. So 4 is the common number in these factor pairs. So it comes out front, and 3 plus 4 goes inside the parentheses. And then you're done. That is it. Okay, so you took this sum of adding 2 numbers and you rewrote it using the distributive property. It's called factoring out. You factored out the greatest common factor, or you pulled out the greatest common factor from each number. Okay? So make sure you have all of those notes written down, and we're going to do a couple more together just because this is kind of weird, like I said before. Okay. So the next one we're going to do is I'm going to have you rewrite 20 plus 25. So first step, find the greatest common factor of each number. So cake it up. Prime numbers. Okay, so 20 is divisible by 2, but 25 is not. So I can't use 2. Neither of them are divisible by 3. Oh, but they're divisible by 5. 20 divided by 5 is 4. 25 divided by 5 is 5. And then 4 and 5 do not have a common prime factor. So the greatest common factor is just 5. Okay, so then we're going to take that to our next step. So I didn't give you the work on this one. We're actually going to write it ourselves. So greatest common factor we figured out is 5. So you need to rewrite each addend with a factor pair using the greatest common factor. So we're going to break down 20 and 25 into factor pairs using our greatest common factor 5. So 5 times what gets me 20? Be 4. And 5 times 5 gets me 25. Okay, so 20 would be 5 times 4. 25 is 5 times 5. Then the next step is to pull out the greatest common factor, which is 5. And whatever is left goes inside the parentheses. And that would be your answer. 5 times 4 plus 5. So one thing I didn't show you in the last one, just because I didn't want to overwhelm you, is the fact that you can check your work. So if just in case there's a chance you went wrong, I would go and actually keep going with this problem. So your brain would do 4 plus 5, which is 9. And this is the check. And then 5 times 9 we know is 45. And if you go back and add your original numbers, 20 plus 25, you should get 45. So you should get the same thing in the end once you check it. Okay? So it's just a nice thing to do if you like to make sure you're doing it right, which I was always that way. So I always like to show you how to check yourself before you wreck yourself. Okay, so this one, I kind of took away the steps of what to do. So we're going to do them together. So I want you to rewrite the sum of 36 plus 8 as a product of their greatest common factor at another sum. So the first thing you're going to do, step 1, is to find the greatest common factor. So we're going to use our cake, prime numbers 2, 3, 5, 7, 11, 13. So 36 and 8, both divisible by 2. 36 divided by 2, 18. 8 divided by 2 is 4. Those are still divisible by 2. 18 divided by 2 is 9. 4 divided by 2 is 2. So 2 is prime, so the only factors are 1 and 2, but 9 is not divisible by 2. So I'm done. I cannot do any more. So 2 times 2 is 4. So there's my greatest common factor of 4. So once you have the greatest common factor, your next step is to write the factor pairs for the two numbers you're adding together. So 36 plus 8. So don't forget you need to use the greatest common factor in your factor pairs. So 4 times what gets me 36? 4 times 9 is 36. And 4 times what gets me 8? Be 4 times 2. Okay, so I just wrote my factor pairs for each addend. Oh, and then step 3, before I move on and change my color, is to pull out the greatest common factor. So this is the reverse distributive property that we did on Wednesday. So the 4 is what they have in common, so that comes out front. 9 plus 2 goes inside the parentheses. Okay, so I would go and check. So if I have 4 times 9 plus 2, 9 plus 2 is 11. 4 times 11 is 44. The original numbers were 36 plus 8, which is 44. So they match, so we're happy. Okay? So I'm going to have you do one more, but this one I want you to pause the video and try it on your own. Okay, so don't forget the 3 steps. Greatest common factor, then you write your factor pairs, and then you pull out the greatest common factor to rewrite it like that. Okay, so try 12 plus 18 on your own, and then when you think you have it, you can hit play and then check with my answer. Okay, so please try it on your own. Okay, so you're back. You tried it on your own, hopefully. Let's see how you did. Okay, so I found the greatest common factor, which is 6. I wrote my factor pairs. So 6 times 2 is 12. 6 times 3 is 18. I pulled the 6 out front, and then I ended up with 6 times 2 plus 3. Okay, so hopefully you were fine, and that's what you got. This is a skill that's weird, I know, and it takes some practice, but I promise that you will get there, okay? So for today's practice, which you definitely cannot skip, you're not allowed to skip this one. You're not really allowed to skip any of them, but I know some of you have been. I would like you in your packet to find the greatest common factor and distributive property worksheet, and there's like a little 1 behind it, because there is 2 of them in there for you. I want you to do these problems. So I was super nice, and I did 1 on each side for you. I did number 1, and then I did number 8. So you have examples right there for you to look at if you forget what to do. Okay, so you have 3 problems on each side, 6 total to practice. Definitely doable. If you have questions, if you're a strictly online kid, email me or jump on my Google Meet. I can do more problems with you if you're not sure what's going on. If you are a hybrid kid, email me. I could always do a Google Meet with you as well at 11:30 if you absolutely needed. But we are going to go over this on Monday of the following week just to help you out, okay? So let me know if you have questions. Other than that, don't forget to do your formative for homework and have a great day.